Thank you very much. Welcome, everybody. So I assume because you're here, you're either implementing continuous integration or thinking about implementing continuous integration. Otherwise, you wouldn't be at this conference. And presumably, you're in this session because you're either thinking about moving to Oracle or working with Oracle at the moment, and perhaps wondering how to get your database development into that process. Any of you not fit any of those? Otherwise, perhaps you're in the wrong room. So you're all using Oracle, I assume. Anyone not using Oracle? Okay, you're not using Oracle. Okay, that's fine. Let's say we're just using Oracle as an example. Oracle is the biggest database vendor out there, so that's why we have built a solution around Oracle. Our Toad products cover a multitude of different database platforms, but the most predominant one is Oracle. So it seems sensible to talk about how to bring Oracle database development into the workflow. How many of you are wrestling with the problem of figuring out how you're going to get your database development processes into an automated workflow? Good. Hopefully we can help you. So I'm not going to talk about, normally these presentations, I'm going to talk about what is DevOps, what is Agile, what is the problem, and all that good stuff. But I think there have been sessions already that have kind of focused on that. One of the questions that often comes up is, given the fact that Agile has been around for so long, over a decade, why is it that database development is still in the dark ages? Why is database development not moved into Agile already? Why is it only now that people are trying to figure it out and bring it in? And I think part of the problem is risk. The state of the database continually changes, therefore it's trying to hit a moving target. Application changes are easy to back out. Database changes are very complicated and risky to back out. So when you're making deployments into a moving target, you've got to think very carefully about, is this actually going to work and not break my running production database? So that's the continuous deployment side of things is not what I'm going to talk about in this presentation. What I'm going to focus in this presentation is continuous integration. An interesting thing is when we look at a lot of database development shops, they're actually not doing quite a few things that they really should be doing that their application colleagues are doing. And that's one of the things that really I'm going to focus on in this presentation. So look at the challenges of adopting Agile in a database environment. And then I'm going to start off by talking about 2 or 3 use cases, because I think this provides some context before we get into what we do. Let's look at the problem first and figure out what the problems we're seeing out there. You will probably, I hope, recognize those problems in your environment. I say these are fairly common. There are common patterns in the customers that we see in terms of what problems they have. And I'm going to be a little bit brave here. I'm going to do a live demo, which is always a little bit risky at these types of things, but I'll give it a go. And then actually show you how you can take traditional database development on Oracle and create some of these processes you may be not doing, like unit testing on your database code, simplify that process and bring it into an automated workflow, and more importantly, bring it into an automated build process that you might have as part of your continuous integration. What's coming next is something that we continue to work on. This is not a finished solution. We have a solution that works. We have customers that are using it. We have customers that are successfully integrating automated unit testing and automated code reviews within an automated build process using Jenkins or Hudson or Bamboo or anything similar. So it works. But we're not satisfied with that. We're looking to improve on that. And so what's coming next is a look at what we're building this year to improve upon what we already have. And then I've got some resources. So if you want more information, there's actually on some of the front row, I'm not sure how many seats we managed to cover, but there are some brochures around which go into detail about some of the aspects I talk about in the presentation. So probably preaching to the converted here, you probably understand the differences between doing Agile database development on the application side, which is the top part of the slide. On the database side, the traditional sort of waterfall approach. The problem that we see in a lot of organizations is they're doing application database development and they're completely different types of processes. So if I could start the automation going, you can see a typical application development team here, checking their Java code or .NET code in source control, triggers an automated build process in Jenkins or Hudson or Bamboo, does a number of different things, test, compile, static code, code review, and then normally then you would just fire that off to your target environment, so you'd have a continuous deployment process. The problem is that we've got dependencies on the database. Your database development is following an entirely different process. So they're doing some of these things, not all of these things, but they're doing it in a very linear fashion. And basically you can't release any of this stuff with database dependencies until the database part has caught up. So this effectively is a bottleneck in your organization, and that's the thing that we commonly see. Is this something you recognize in your organization? So what we have to figure out is how do we change the way we do our database development so that instead of having 2 to 3 month release cycles on your database side, we've got to try and achieve what is being accomplished on the application side, which is a much shorter release cycle. So we have to redefine the way that we do our database development. So we have to try to figure out how we're going to shorten our release cycles without compromising quality, without compromising the integrity of the code, without compromising the performance and scalability of the code. It's very easy to say, oh yeah, we can achieve Agile, we'll just do things faster. But then you end up with junk code hitting production faster than you would have done before. So you're not alleviating the problem, you're actually aggravating the problem. If you just crank the stuff out faster and try to cut corners. So cutting corners doesn't work. So you've got to start looking at ensuring quality. There's been a couple of presentations yesterday that really said, made this point that when you move to Agile, it's not about cutting corners and forgetting about quality and reliability. You've actually got to do more of that because now you're in an automated pipeline. But if you can achieve that, then you will reduce risk because now you're delivering incremental value to the business at lower risk than you would have done if you deliver massive value at the end of 3 months with a high value, with a high risk, and then you can lower costs to the business as well. So what I'm going to focus on is these 4 boxes here, which we can deliver into a continuous integration environment. It starts off with tracking your code changes. So by that I mean version control, using version control. This is paramount. If you're doing database development and you're not using source control, frankly, you're mad, unless you're in a very small team. So imagine most of you, if not all of you, are using source control. Anyone not using source control in their database development environment? You're probably not going to admit it if you don't, right? Then we have to automate unit testing. Now, it's probably a bit of a leap here. How many of you are already doing some kind of unit testing on your database code? Some of you. All right, what about the rest of you? No. So you're releasing database code untested. Okay. So you've got to think about testing, which is hard, right? Testing database code, Oracle PL/SQL code is difficult. It's very timely. And you end up writing a lot of other code just to test a program. And then you've got to think, okay, now I'm doing testing, I've got to figure out how to automate it. All right, so when I say automate unit testing, I'm making the assumption that you're doing some testing anyway. But if you're not, that's the first hurdle you have to overcome. And when we go to see different customers, that's the first hurdle they have to overcome, is, well, we're not doing any testing. Well, that's your starting point right there. You've got to start doing testing. So start testing your code. Code reviews. Now, this is done in a manner of different ways. It's a bit piecemeal. It's very lightweight. It doesn't focus on all of the code, and it's very subjective. Right? I give a piece of code to one of my colleagues, ask them to check it over. Yes, that's fine. I get what it's doing, but it's not really properly documented. It doesn't look at best practices. It doesn't look at the techniques that are used. It doesn't look to see if you can leverage any of the newer technologies on later versions of Oracle, for example. That type of thing. So you want something that's much more objective, something that's a bit more scientific, but also something you can ultimately automate. It's got to be repeatable. Okay? And then the fourth one is tuning. Now, tuning is always a challenge, I think, for most developers. It requires some experience and knowledge of what you're doing. I speak to developers a lot and say, how do you do tuning? Well, I'll look at the execution plan. Great, then what? Well, I'll look some more and I try a couple of things and I sort of give up after an hour because I can't get my DBA to do it. He's too busy. And what happens is that poor SQL executions and poor code executions manifest themselves in production, by which time it's too late. Right? I mean, the cost of fixing it in production is exponentially more expensive than it would be if you'd have fixed it in the first place. The problem is that developers don't have the experience to tune SQL in development, and generally speaking, it's difficult to get good tools that will simplify the process. So having the ability to simplify the task of tuning code in the database is a challenge. And hopefully you'll see that we have a way in which we can do that. We've had tuning tools in Quest for many, many years, but it's only until relatively recently that we've simplified the workflow to a point where it's literally a couple of mouse clicks and you can fix the problem. Right? Now, prior to going into test and production, of course, the DBA may have other ideas about what makes sense for the environment, but at least if the development shop can fix most of the fundamental problems with the code and the SQL statements, you can deal with a big chunk of the problem before it gets into production, okay? So let's look at, first of all, let's create some context. Let's look at some of the customer users. So these are actual customers. I haven't named the customers, obviously, but I've said kind of what sector they're in. So this is a US-based customer, East Coast, financial services company. They have a lot of developers, about 9,000 developers in US and India. The business, look for the common threads here. The business requires them to shorten their release cycles. 3 months isn't cutting it. They've got to have 2-3 weeks release, 2-3 weeks release. In this particular example, the CTO team has been tasked with figuring out how to do that because they're supposed to be the experts. So they have to figure out how to do that for their Oracle development teams without compromising quality, performance, and scalability. That's what their business has said. They've got people that are already using Toad as a desktop tool, but they have no idea how to get it from that into a way that can be part of a CI process. They have done 0 PL SQL unit testing. So they don't test their database code at all. They have code quality issues, which have resulted in rework, as you would expect. If you're not testing your code, you're not reviewing your code, what's going to happen? How many of you experience some sort of issues with code that's not worked well in production? It's either functionally not worked at all, or it's failed for some other reason, or the quality wasn't good enough and you had to come back and fix it. Yeah, it's a fairly common problem. I mean, don't be shy. It happens a lot. So you cannot afford to have code that has to go back to development for rework in a continuous integration environment. That kind of defeats the object, right? Their application teams are already using, in this case, Jenkins. They're all using Subversion. They're using SVN, but they're moving to Git. So they've got many of the pieces in place. This is another example. This is another UK financial services company. Again, common thread here, the business is requiring short release cycles. Now this is the same in all cases when you look at who's driving this. It's not the IT. IT will just leave things as they are. Why change it if it's not broken? Well, the business is saying, this is no good. Release cycles are too long, you need to shorten them. You need to work with the application teams. They did some manual PL SQL unit testing. So they wrote PL SQL unit tests by hand, which they documented in an Excel spreadsheet. So, okay, they did a little bit of testing, but it's certainly not the type of testing that you would need if you're going to automate it. And some code reviews. They set up a project team, they did a proof of concept on our solution, and they're moving ahead with a pilot project. Their initial task, though, was to define unit tests. So this is not even test-driven development. This is like a legacy project. And so it's a case of, well, we've got all this stuff, let's create some unit tests for the code that we've already written. If it was a brand new project, you'd start thinking about test-driven development. And finally, again, this is a US company, food service distribution company. Business requiring short release cycles. They've actually appointed a DevOps engineer. Now this is an interesting thing as well, is they appointment, I had to sort of question it. So you've actually brought someone in from outside the organization to manage this whole thing? Yes. Good luck with that. What we see in most places is the person responsible for the whole deployment pipeline is somebody who's already in the organization, familiar with the applications, either drawn from the admin side or from the dev side, with experience of both. Someone like a development DBA would be a good example. How does it work in your organizations. Who in your organization typically would be responsible for something like this? Bringing a traditional development into a continuous type of process. Right, right. Anyone else? Similar? Anyone actually have somebody who has a title of DevOps engineer? What, a couple of you, okay. Yeah, so this is what we had here. They did some manual testing. They actually want pass-fail reporting back in Bamboo. So they want to have, they actually specifically said we want to do code testing, but we want to have the unit tests and the code together, because obviously as the code evolves to new versions of code, then you might have additional unit tests that weren't relevant to an earlier state of the code. So they actually specifically wanted unit tests and code checked into source control. And then when they run the automated testing, they want to have reporting back inside of the build process for the database code, the same as you would on the application code. They're using Bamboo, they're using SVN and Git, and they're looking to eventually deploy into a hybrid cloud infrastructure. So, you know, a variety of different use cases, but some common factors. Okay. All right, so in the demo, basically going to start off with some of the items I covered in those 4 boxes. So basically source control, integrating source control, taking some of the basic functions like unit testing, creating unit tests for your PL SQL code, performing code reviews based on your coding standards, and tuning SQL. So the first thing I want to start with is source control integration. So in Toad, which is what I'm using here, we have Toad on different platforms. This is a Toad on an Oracle platform. We have a way to integrate with a number of different source control systems, like Git, so TFS, ClearCase, Perforce, SVN, some others. But the way that we enable source control integration is to make it as simple as possible for the developer. What you don't want to have the developer have to do is to go into the source control provider's own UI and check files out of source control into their own environment, and then go into an IDE and open those files into the editor and start working on them. What you want to be able to have the developer do is just basically work on the database object. Right? That's natural for them. You know, select a table, work on it, make some change to the table. Open a package, work on the package, compile it. All the back-end stuff, the file system stuff, so just take care of itself. So what we do is we have this thing called team coding, which is a way to integrate a source control system and its file system with the database objects, the corresponding database objects in the database schema, and keep them in sync. So every time a change is made to a database object, we update the file to its next version and check it back into source control. Make sense? So you separate out the task of working with the files in the source control system from what the developer's really trying to do, which is work on the database object. And if there's some reason something gets out of sync, then the developer will be told that this is out of sync. Somebody may have, you know, gone into SQL Plus and done something and not checked it in. Now the code in the database is out of sync. They'll be told that it's out of sync, and they can compare them side by side, and they can either merge, or they can say, well, actually, this is the right version, or whatever. They can make that decision. You can also, when you're doing this, you can optionally have some policies built in. So what happens is when the developer's making a change to, say, a store procedure, you could have a policy that says, okay, when you're about to check this store procedure back into source control, run all the unit tests, run any unit tests associated with the store procedure first. Because if any of those unit tests fail as a consequence of what that developer's just done, you don't want to have that in a build, because it's failed some tests. And you can do the same thing with code reviews. So if you set up your code review, you can have a policy in this that says, when you're about to check this code into source control, first of all, does it meet the minimum quality checks? Because if it doesn't, I don't want it in this build. So you can reject it, and the developer can get a notification that's been rejected, and they need to fix the problem before it's allowed to be checked in. So that's a very simple way that you can deploy things like unit testing and code reviews on the fly at the point the developer's checking code back into source control. Okay, so this is Toad for Oracle. I'm connected to an Oracle database here. This is my different connections. I'm connected to a local database here, and this is kind of a development environment. In the middle section here, you can see some different tabs. By the way, how many of you are already familiar with Toad? All right, so for some of you, you've never even seen this before. So this is a typical, screen that we'd see if you were using Oracle or SQL Server or DB2, similar sort of layout. So you'd have some sort of database browser, or in this case, called a schema browser. You can select different schemas from here and view the objects in there. The objects are broken out by tabs, or you can have a tree view. It's entirely up to you. And then when you click on an object, we expose different tabs on the right-hand side, which look at how this object is set up. Is it set up with team coding? Has it had any unit tests against it? And so forth. And then when you're ready to open something up, you can just load it into the editor. And in this particular case, I can have it checked out. So for example, if I want to work on this store procedure here, I've already got my team coding set up. If I look at my configuration of my team coding, I can see that I've got the ability to set up different projects. These projects correspond to projects in my source control system, in my case, Subversion. I can have multiple projects across multiple schemas. I can even have a project that has objects from multiple schemas in it. This particular example here has got database objects from 2 schemas in one project, so you're not limited to one project, one schema type of thing. So I can manage these different projects in different ways. I don't have to have them set up the same way. So for example, if I wanted to enable the ability to quality check the code on this project at the point where it's checked in, I say integrate with code analysis, which is our code QA tool. I set up my minimum quality levels. So I can say, well, one of the things I want to do is make sure that the check-in metrics are lower than check out. In other words, I don't want to have a situation where the developer's checking code in where the quality is worse than it was when they checked the code out. That wouldn't make any sense. So that might be a policy I want to enforce. So I check this box, and if for some reason the developer's done something and lowers the quality standard of the code, they wouldn't be allowed to check it in until they fix the problem. Make sense? So I can configure that. Let's cancel out of there. So I can set this up in different ways. In my particular case here, I've set it up so that when a developer double-clicks the object to open it into the editor, it simultaneously checks the code out of source control. If I haven't already logged on, it gives me the login screen, and then it will perform a checkout. And you can see at the bottom of the screen there, it's checked out. So now I can work on this code, make any necessary changes, and then have it checked back in again. On the left-hand side, you can see I've got a way to look at all of my projects that are being controlled. In this particular case, I'm working on a store procedure. And you can see here that this store procedure's got a different icon, which indicates that it's been checked out. There it is, status is checked out. I've also got a different perspective, which is the VCS perspective. This is now looking at my Subversion system. And it's in this top one, is it? Yeah. So these are my store procedures, and in the Subversion system, it's also indicating that it's been checked out. So I can keep a track of the files and the database objects. Okay. So that's the source control integration. In terms of testing code, all that you would do is we have a part of the Toad package which includes a unit testing tool. It's called Code Tester. But the way that we've implemented it recently is you can create simple test cases simply by running the code. So if I went and actually executed this code, this is a really simple example. It's only got a single input parameter. So I'm going to change the input value here to A. It's got a single output value. It's going to run the code. It generates the anonymous block here to call the code and run it with that input parameter. So I go ahead and execute that store procedure. That's finished. If I go and look at in here, you can see that it displays the output as well. So there's my input value of A. The output was this number here. And that's really all you need to create a use case of a unit test. So that's a use case. What I did there was that input value. You could do it with a package or anything obviously more complicated. I'm just picking this as a simple example. So if that's a situation you want to repeat, so we want to capture that as a use case, you say create unit test. And test 65 or whatever. That's the name of my test. Click OK. And that's now created that as a test, which means that it gets stored in the repository, and I can call it, and it becomes part of my regression testing. If I come back into here, and let's do a new connection. So this is the actual testing environment itself. What I want to do is make a connection to that. And my database is this one. Connect. So what I can do in here is I can look inside of the test repository, and I just want to show you that this test that I just ran, which was in this store procedure, test 65 is there. So that's the test I just created. And if we look at the test code, so what this tool does basically is based on that input value and either the expected outcome or the actual outcome, depending how you do it. If you go in the actual testing tool itself, you can follow test-driven development. So you can say, well, if I use this input value, I would expect this to happen. And that's my test case. So you can create test cases ahead of the code, which is, in a perfect world, that's what you would do. In this particular case, the output was generated, and it created a test package. Okay, and my test package, recompile. Let me just find another one real quick. So this is a package, that's the package spec, this is the package body. So this is a similar test here. This generated about 670 lines of code. You know when I said that creating unit tests for PL SQL code is hard? That's why. You generally end up writing about 10 times more code than the code unit that you're actually testing. That's why no one does it. You know, so having the ability to just create unit tests very simply by running the code is going to be very beneficial to developers. Okay. What about code reviews? Well, if I want to run a code review, I can run that just by selecting this button here and just say analyze the code. It will do some quick checks of the code, looks at various DML operations that are going to be performed on that code, which objects are being used, and then give me a list of violations. Now, the coding violations are really depend upon what you decide is the standards you want to work to. So what you can do is, if I go to code analysis, which is the code review piece, I can define the rule sets that I use. So rule set is an encapsulation of rules that define your coding standards. So these are some that come with Toad, but you can create your own rule set based on your own coding standards. And this has about 200 different rules that you can select. So I'll just show you some of those. So they look at program structure, maintainability, readability, code correctness, efficiency, and things like that. So you can make selections from those. They also come in the form of severities, so you can have warning ones, informational ones, and so forth. So it's down to you what you decide reflects the coding standards in your organization, and you encapsulate those into a rule set, and you apply that rule set across your team. So everybody's following the same standards, and it's objective. And it can be not only applied consistently, but it can be automated too. So let's look at automation. So automations can be created in Toad. This is something that's been around for a long time. So here I've created an automation. This is a thing called Automation Designer, and I can select different things to automate. So these are basically Toad functions. And here I've got one for unit testing, I've got one for code reviews, and this example has both. So if I look at the first one, for example, I want to run in this automation, I want to run a unit test on this stored procedure. Okay? and I want to publish the results into our Toad server. So we have a piece called Toad Intelligence Central, which is a server application, and publish the results centrally. That's an essential part of bringing this into a continuous integration workflow. Similarly with code reviews, I want to run a code review on any code that's in this case, it's just one, it's the same store procedure. So I'm running a code review. I can select the rule set from here, which is my, what quality levels you want. And this is now encapsulated in automation. What that means is that I can publish this encapsulated object into a server application by selecting the automation here and clicking on this link here, Publish App to Intelligence Central. Intelligence Central is a web, has a web server piece to it as well. And this is an automation here that came from the desktop tool. So there it is inside the desktop application. There it is inside the server application. And I can run that on the Toad server. All right, and it will behave in exactly the same way as it would have done if I ran it on the desktop tool. Okay. So let's come back to here and just refresh ourselves with this. So we talked about integration with source control. We talked about how to create automation artifacts and publish those. And they would include things like unit testing. By the way, if I want to do more sophisticated unit testing, rather than just simply running a code with a set of input values, I can launch this tool and create something a little bit more comprehensive. So here, for example, if I connect here, I'll just show you a real quick example of how you can follow test-driven development. So this example here has predefined use cases. So this is testing for first name, last name, gender, title, for different conditions. So I've created a whole multitude of different use cases here, and I can run those tests against the current state of the code. So if I run that at the moment, it'll come back and say, well, it's failed simply because the code that you have doesn't have all the implementation information yet, which is, it's in a different schema. So here. Right, so here's a function called salutation. You can see it really doesn't have much in it at the moment. Check it out from source control. All right, so there's very, very little in there, okay? If I was to load in some more implementation information, I'll do that just by loading in this file here and compile it. This is basically, you can see now it's got more information, it's got more implementation information in its code. Go back to code tester and rerun the test. Let me recompile the test code. Actually, you can see here that now some of my test cases are passing. Okay, and these latter ones, so I've got one that failed, and some other ones that were later on actually passed for some reason. So something actually regressed here. And so what I can do is I can go back to Toad and run the debugger on this code and look at the code coverage under those conditions and see what caused that to fail. Fix the problem, and then recompile it. So if I load in, let's cancel out of that. So if I load in another one, this one here, and compile. So this 4.1 example is one where the problem has been fixed. So if I come back here, recompile my test code, and rerun the test, what I'm expecting is that 2.3 is fixed, which it has been. So I fix that regression, and then I can continue with the testing. So this shows you how you can use a testing tool to follow test-driven development, creating test cases up front, and then build the code, and then seeing at what point code breaks, if it breaks, and then fix the problem. And you can do this each time. You can even do this on the fly. So if I'm inside of Toad, and I'm working on that same piece of code, then I could execute this code and run the test cases as well. Okay, so let's come back to here. So that's the code reviews, and so the other thing is the SQL tuning. So if I do a SQL tuning, let's pick this one here. So in this example, I want to show what if I've got a problem with a PL SQL program, like a package or a store procedure or something like that. You know, how do I tune it? Usually they're going to run slow because you've got an embedded SQL statement that's running slow. And that's true in this case. If I look at the profiling data, so there's a way in Toad where you can profile the code to examine how long each line of code took to run and compare them. So if I just look here, if I look at this is an example here where it's taking, right, so this one here, this is one where we've got a problem. So when this store procedure runs, it's taking 29.9 seconds to execute. You imagine that running in a production environment. It's going to run a lot slower than that. I was able to identify that using a profiler. I was able then to tune the SQL statement. So going back to here, and then finding the SQL statement, clicking on it, clicking a tuning tool. And the tuning tool is going to, basically it's going to reform the SQL, because remember we're pulling this out of a store procedure. So we reform it, and then that's click number 2. And then it's going to start looking for, and now it's substituted a local variable with a binary variable. That'll only happen if you've got locally declared variables. And now it's going to generate alternative rewrites. So what it's going to do is going to use an AI algorithm to figure out how many different ways can I rewrite this statement where the execution plan is different, but gives me the same data, which is very important. You want to have the same data. And it will return me some alternative statements, as you can see on the left there. So what I can do then is to compare the before and after. So I can compare the original SQL statement that I wrote with some alternative ones, and based on the execution plan and the execution statistics, I can decide which one I put back into my application. And then what I can do is, if I look at the profiler, so I'm going to compare now the before and after, right? So before I tune the SQL, after I tune the SQL. All right, so that was before I tuned the SQL. I went and tuned the SQL statement. It found a better alternative than the one I'd written. I put that back into my store procedure, reprofiled it, and it was a fairly significant performance gain there. So that's what we mean by automating SQL. What you don't want in an agile development environment is to be slowed down by developers trying to figure out how to tune SQL statements. That doesn't lend itself to agile. So if you're going to move to agile, you want a really fast, effective way to identify poorly executing code, poorly executing SQL statements, and tune them. And then finally, the Toad Intelligence Central piece, which is where different developers can collaborate, and where we can publish our automation artifacts that we showed you earlier. They can be accessed from your continuous integration process. So how does that work? Well, what we do is so remember the automation that I published onto Toad Intelligence Central. I'll just go back and show you that real quick. So here's my window that's showing me my connection to Toad Intelligence Central. This uses Windows Active Directory integration, by the way, so it's very easy to create up groups of users and roles based on Active Directory, set up access rights, and what you can do then is you can take that automation. So this automation, remember, had code review and a unit test, right? So that's what I'm going to run. But what I want to do is, instead of just running it, I want to be able to run it from a build process. So what I do is I generate what's called an execution URL. Okay. Now an execution URL is, if you consider, say, Jenkins, for example, you want to be able to do a remote access to the Toad server that contains the automation, and you want to do that from, say, Jenkins. So in this example, Jenkins, the way that you would do that remote access API is you'd use a curl statement. Anyone familiar with curl? Okay, some of you. So this is basically a way that you can take your build process and do a remote access call through a REST API and run something on a remote device. Okay? And that's what we're doing here. So we generate that for you. So that's effectively what that is. That is URL. So this becomes part of an HTTP post method. And that enables you then to take that automation and run it from a build process. Okay, and here's an example down here. All right, curl, and then it's running the Toad executable on the server. It's running a post, and then it's got that's this string here, and that basically tells Jenkins to run this automation on the Toad server and run whatever's in that automation. Whatever's in there. It can be schema compare, data compare, unit tests, code reviews, whatever. So what we do finally then is we basically bring application and database development together. So when you do your build, you're combining your application code and your database code together into that build. Make sense? Questions? I know probably not that much time for questions, but any questions?
The tests that you showed, can I see those in a code format, source control?
Yes, absolutely, yeah. So one of the things that some customers said is that, you know what, those tests are great, but because the code evolves, so does my unit tests. So I want to check in my source code and my unit tests as a matched pair. Yes, you can.
The test, what you call from Jenkins, does it return some result on how Jenkins can understand if the results failed or not?
So at the moment, because we're using REST API, it's somewhat limited. The test results are actually on our Toad server. All right. If I show you this real quick, this is what we're doing next. So I said this is not standing still here. We're moving on to the next thing. All right. What customers actually want to be able to do is orchestrate everything from here. What they don't want is another server in their environment and something separate. So what we're doing is enabling the same functions, so the same function calls, if you want to call unit tests and code reviews and all that kind of stuff, but make it callable as a script from your build process. So same thing, but the benefit of doing it this way is that any results that get generated, code review results, unit tests results, pass, fail, that kind of thing, gets back into your build process, which is what we don't have at the moment. All right, so this is coming later this year.
How would you unit test DDL? So like adding a new column to a table or something?
So with tables, what sort of things are you going to be looking to test? I mean, with a functional code program, you're looking to test the functionality of the program. That's what the unit test is for. But for tables, and what sort of things are you looking to?
Well, I don't know what I'm looking to do. I know the problem I had was I worked with developers who use a lot of Hibernate, so they would randomly add new properties to classes. Oh, I see. And then they would frequently break because they hadn't told me. So, right. We hadn't caught the addition of the columns on my side.
Yeah, so the testing that we have is purely for code, not for tables, constraints, indexes, things like that.
Yeah.
Yeah.
Thanks.
But objects like tables and constraints and indexes you can have in source control. So that team coding thing I showed you can include, it's not limited to code, you can have tables. So if somebody wants to alter a table, or somebody tries to alter a table, if it's being controlled by team coding, it'll say, you need to check this out first. I'm not going to let you alter this table unless you check it out. And then they can make their alter table and then check it back in again. So you have a rolling history of all the changes. Yeah.
Can I just say we are just heading out to lunch. There's plenty of time if you want to hang around. Obviously, get your questions in. But for everyone else, lunch is about to be served on the 5th floor. So thank you very much. But please do hang around and ask questions as well.